This video is Integrated 3, Chapter 5, D-Day, D-Day number 3. So on this, they're asking us to graph this. And there is a critical point here, locator point 2, 1. And what we want to look at is whatever makes this 0, we cannot take log of 0, so that will be an asymptote. So that is going to be at x equal 2. So let me plot that first. Okay, so I'm going to plot that. X equal 2. Okay, that'll be an asymptote. And I'll label it x equal 2. Then what I'm going to do, I'm just going to jot down some values here. This is log base 3. So when I'm doing log base 3, I want to think about 3 to powers. Okay, like 3 to the first is 3, 3 squared is 9, 3 to the third is 27. So log base 3 of 0, okay, remember 2 made that 0, is undefined. That's why there's an asymptote at 2. So log base 3 of 0 would be undefined. Log base 3 of 1 would be 0. Log base 3 of 3 is 1. And the next nice one would be log base 3 of 9, which is 2. So this critical point, this locator point here, 2, 1, I'm going to come over here to 2, 1. Okay, 2, 1, which is right here where this red dot is. Okay, right there where this red dot is. And that's where I'm going to go out 1 and 3 and 9 and 27 and 81, all 3 to powers. Okay, because those are nice ones. So when I'm doing this and I go out 1 from here, log base 3 of 1 is 0. When I go out from here 1, 2, 3, log base 3 of 3 is 1. And I'm not going to be able to fit 9. But the graph is going to be coming like this. And getting closer and closer to x equal 2. Now, I'm going to plot also the inverse of this. And so when we're plotting the inverse of this, if our asymptote is at x equals 0 for this graph, then the inverse is going to have it at y equal 2. And then if I have a point here, I'm just gonna change the color of this real quick. Let's see if I can click on it to blue. Okay, so that kind of matches with this asymptote. Okay. Then when I am going to be plotting the inverse, again, if it was x equal 2, the inverse of that will be y equal 2. This point right here, which is at 3, 1, is now going to be at 1, 3. So I'm going to go to 1, 3 and put a point. And then this point over here, which is 5, 2, is now going to be 2, 5. So I'm going to put a point at 2, 5. And this is an exponential graph. So this is going to be an increasing exponential graph like this. Okay. Now to find the actual equation of the inverse, I am going to take this, remember this is really just a y, okay? And I'm going to switch x and y. So I'm going to go x equal log base 3 of y minus 2 plus 1. And so I need to first get rid of this plus 1. That's always going to be my first step with this problem. So when I minus 1 from both sides, I get x minus 1 equals log base 3 of y minus 2. Now, at this point, once this is isolated by itself, I'm going to rewrite it in exponential form. And the thing to remember is that logs always equal the exponent. So that's going to be my exponent when I rewrite it. So I'm going to rewrite it base of 3 raised to the x minus 1 is equal to y minus 2. I'm going to add 2 to both sides. And then I get 3 to the x minus 1 plus 2 equals y. And that is the inverse. On number 2, A and B, we are going to be graphing these, finding the asymptotes and stating the domain. So on this one, this is log base 2. So let me just jot down some log base 2s here real quick. So log base 2 of 0, log base 2 of 1. I always do 0 and 1. And then I always do whatever the base is next. So log base 2 of 2. And then we're doing 2 to power. So the next one would be 4. And then 8 and 16 and so forth. So log base 2 of 0 is undefined. Okay. That's always my asymptote. Log base 2 of 1 is 0. Log base 2 of 2 is 1. Log base 2 of 4 is 2. So looking at this, I have a critical point at -3, 3, or a locator point. And then when I'm looking at this to see, hey, what makes this 0? The thing that makes it 0 is x equal -3. So that's where my undefined is going to be. That's where my asymptote is going to be at x equal -3. So I'm going to be putting an asymptote at x equal -3. Okay. And then I'm going to be graphing my graph. And that critical point, -3, 3, okay, this is where I'm going to go out 1 and 2 and 4. And the next one would be 8. I might be able to fit that on here. So let me just get a bigger pen. Okay. And change the color. Okay, so again, at -3, 3. So I'm going to go out 1, log base 2 of 1 is 0. I'm going to go out 1, 2. Log base 2 of 2 is 1. So I'm going to go up 1. I'm going to go out 1, 2, 3, 4. Log base 2 of 4 is 2. And then if I went out 5, 6, 7, 8, log base 2 of 8 would actually be 3. 1, 2, 3. And then my graph is going to go like this. Whoops, I'm going to make it a little thinner. It is going to go like this and get closer and closer to this asymptote. Now, if you're looking at the domain are x's. And so I'm just going to do a vertical line here. And I'm just going to be moving it across this to talk about the domain. So domain is going across left to right. So the furthest that to the left this graph goes is here at -3, but it doesn't touch -3. So I'm going to have an open bracket. And the furthest to the right this graph goes is it keeps going to go out forever and ever and ever to infinity. Okay. So my domain is going to be open bracket -3 to infinity. So on letter B, we have another logarithm. Okay, this one's a negative. And all that means is after you do your log, you're just going to multiply what you would normally get by a negative. That's it. So let me just move this out. I have that here for domain. Okay, so this is base 5. So when I'm doing base 5, I am thinking that this is going to be log base 5 of 0, which is undefined. Log base 5 of 1, which is 0. Log base 5 of 5, which is 1. And that's the next nice one will be 25. So we're obviously not going to get there. So I'm concerned with what would make this be undefined. What would make it 0? Okay, so what makes this 0? Because whatever makes that 0 is going to be my asymptote. So that's going to be at x equal -2. And then kind of my critical point or my locator point is going to be -2, -3. So let me draw my asymptote in at x equal -2. And then I'm going to have that critical point at -2, -3 down here. And so -2, -3, as I go out 1, remember this is base 5, log base 5 of 1 is 0. And then I'm going to times it by that stretch, which is negative, but a negative times 0 is still 0. So I'm going to go out 1, 2, 3, 4, 5, and log base 5 of 5 is 1, but I'm timing it by a negative, so it's going to be a negative. So this is going to be going like this. Okay, so let me connect that curve. Redraw that. Move this a little. And that's my logarithm. Okay, and really it should be going towards it, not away from the asymptote. Okay. And then they want domain. So again, my domain is going to be my x's that this graph has. So as I go across this graph, furthest to the left this graph goes is -2, but it doesn't touch -2, so it's open. And the furthest to the right it goes is forever and ever to positive infinity. So this is going to end up being -2 to infinity. So on these bottom ones. Okay, so sometimes it helps to rewrite these in exponential form if it's as a log. So I'm going to rewrite this. This is going to be 4. And the thing to remember is that when we are taking the log of something, we're trying to find the exponent. That's going to be the exponent every single time. Okay, so that's going to go right here. So log base 4 of -4 equals x. Now, remember, a negative is going to flip it. So 4 to the 4th, well, 4 to the 3rd is 64. And 4 to the 4th is 256. So this is going to be 1 over 256. And that is our answer. Now on letter B, this is really saying 8 to what power? Because again, remember this, that the log is equal to is always your power, is equal to 1 over 256. I want to get these to be the same base. Let's see. 8 squared is 64. So I can't use that. 8 cubed is 512, so that's too big. Now I know that 256 is 4 to the 4th, but 8 is not going to be 4 to a power. So I'm going to have to break both of them down. So I'm going to break both of them down to 2. So this is going to be 2 to the 3rd raised to the power x. And then 256, since this was 1, 2, 3, 4 fours, each of these is going to be a 2 squared, 2 squared, 2 squared, 2 squared. I'm going to have 2, 4, 6, 8. So it's going to be 2 to the 8th. It's really going to be a negative 8 because it's 1 over. Okay. Then this is going to be 2 to the 3x is equal to 2 to the negative 8th. I'm going to set my exponents equal. I get 3x is equal to negative 8. So x is equal to negative 8 over 3. On letter C, if I rewrite this, this is going to be x to the, again, remember, this is always equal to the exponent. So x to the negative 3rd, negative 1/3, sorry, is equal to 6. Now, a couple ways you could think about this. One way is to remember that a fraction is a root, so this is really the cube root. But another way to do it is I want to try to get this x to the negative 1/3 to really be x to the 1st. So what I'm going to do is I'm going to raise this to its reciprocal, which is a negative 3, and I'm going to do the same over here. And so when I do that, I end up getting x to the 1st, or just x, and 6 to the 3rd. 6 to the 3rd is 216. Let me just jot that down. So 6 to the 3rd is equal to 216. So this is going to be 1 over 216 as our answer. Okay, on number 4, we want to find this inverse algebraically. So I'm going to switch my x and y. And then you want to pay attention to trying to get the y by itself in the order that we should do things in. So the first thing I'm going to do is get rid of whatever's being added or subtracted here. So I'm going to have x minus 10 is equal to 2 times the quantity, y minus 9 cubed divided by 5. And then what I'm going to do, and I could do this a couple different ways, but I'll just do it this way. So I want to get rid of the 2 and the 5. It's a 2/5 I want to get rid of, and so I can multiply by 5 halves. Or what I can do is do each of them separately, get rid of the 5 first, and then get rid of the 2. So maybe I'll just do that. So I am going to multiply this by 5 and then multiply this by 5. And so I'm going to get 5x minus 50 is equal to 2 times y minus 9 cubed. And then I want to get rid of this 2. So I'm going to divide by 2. Okay. I'm going to divide this side by 2 and this side by 2. And when I do that, I'm going to get 5x minus 50 over 2 is equal to y minus 9 cubed. And then I need to get rid of the cube by cube rooting. So I'm going to take the cube root of 5x minus 50 over 2 is equal to y minus 9. And the last step is to get rid of this minus 9. So I'm going to add 9 to both sides. I'm going to put the 9 in the front, 9 plus the cube root, and that whole 5x minus 50 over 2 is all underneath the radical is equal to y. And that is our inverse. On number 5, we're asked to find f of g of x. So with these, what we always do is we're going to start with the inside. So the first thing I'm going to do is find g of x. And I know what g of x is. G of x is equal to x cubed plus 1. So this x cubed plus 1 is now going to go here in my f. So I want f of x cubed plus 1. And then my f, this is my equation for f. So I am going to have 2 minus my x, and my x is this x cubed plus 1. So I have 2 minus x cubed minus 1, which is 1 minus x cubed. And that's our answer. So on number 6, we're going to find the vertex. I'm going to use completing the square. So first thing I'm going to do is just take that 15 and add it to the other side so that I can complete my square easier. So I'm going to go y plus 15, give myself some space, is equal to x squared plus 16x. Then what I want to do is I want to look at my b, and whatever my b is, I'm going to split it in half. So I'm going to take 16 divided by 2 is 8. And then I'm going to square that, which is going to be 64. So I am going to have y plus 15, okay, x squared plus 16x. And then I'm going to add that 64 here and add that 64 here. And then I have y plus 79 is equal to the quantity. And this is going to be an x plus 8 squared. My last step is to subtract that 79. So I'm going to have x plus 8 squared minus 79. And now it's in the nice vertex form. And so my vertex is going to be equal to negative 8, comma, negative 79. And that's my vertex. On number 7, on one like this, when we see that we have this square root of x minus 3 in both of them, I am going to let u equal the square root of x minus 3. Okay, let me just color code that. Okay. So now I'm going to rewrite this. So I'm going to have 3u to the 4th is equal to 27. And this is 3, and it's going to be u squared. So now what I want to do is I want to get both of these to be the same base. So I want this 3 and this 27 to become the same base. So I'm going to make both of them 3 to a power. Well, this one's going to stay 3u to the 4th. And this 27 is a 3 to the 3rd. Now let me do it this way. 3 to the 3rd, that's being raised to the 3u squared. So this side is still 3u to the 4th. This side, we're going to take power to power and we're going to multiply. So that becomes 9u squared. So now I can set my exponents equal. So I'm going to have u to the 4th is equal to 9u squared. I'm going to get everything on one side, 0 on the other. So I'm going to subtract 9u squared. I can take u squared out of both of them, and I'm left with u squared minus 9 equals 0. And I've been nagging us about recognizing differences of two squares. So that's a difference of two squares there, right? We've been factoring those every week. So it's going to be u squared, and this is going to be a u plus 3, u minus 3 equals 0. So I have a u equals 0. Actually, I have it as a double, but because I have it twice. But we only have to list it once. And then this is going to be u equals -3. And then this is going to be u equals 3. So now I'm going to go and look at this that u is equal to. And so let me set those equal. So I am going to have the square root of x minus 3 equals 0. I'm going to square both sides and get x minus 3 equals 0. Add 3, I get x equal 3. That's one answer. Let's see, I've got a -3, so I'm going to take x minus 3 is equal to -3. Now, when I do that, I want to stop. I want to look over here. That's a negative. This square root means principal root. It needs to be a positive root. So that means it cannot be equal to a negative. So this would be no solution. That's not going to add any answers. On the last one, we're going to have the square root of x minus 3 is equal to 3. We can work this out. We square both sides. We get an x minus 3 equals 9. And I add 3 and I get x equal 12. So I have a 12 and a 3 as an answer. And on the last one, number 8, we're looking for x-intercepts. So to find an x-intercept, you put 0 in for y. So let me just write this out. 6x to the 4th minus 21x cubed minus 45x squared. I actually can do, because this is an equation, I notice that everything could be divided by 3 just to get my numbers smaller. So it's going to be u is equal to 2x to the 4th minus 7x cubed minus 15x squared. Then I notice that I've got all of these x to the 4th, x to the 3rd, x to the 2nd. The smallest one I have is x to the 2nd, so that's the most I can take. So I'm going to have 0 is equal to, I'm going to factor out an x squared. I'll be left with 2x squared minus 7x minus 15. And again, we've been practicing factoring every week. This, hopefully we can factor further. This would be one of the box to diamonds. So let me just do a box to diamond. So I'm going to have a 2x squared and a -15. I want it to multiply to a -30x squared and add to a -7x. And we really have to pay attention to the signs. Some of us have been a little lazy with signs lately. So this negative here means that these are going to be different signs. One's going to be positive, one's going to be negative. This being a negative, this being a negative sum means that my bigger one's going to be negative, my smaller one's going to be positive. So I really want them to multiply to 30, but subtract to like a 7. So that's going to be a 10 and a 3, 10x and 3x, -10x and a positive 3x. So I have a -10x and a positive 3x. So the 2x has to get the 10, the x will get the 3, plus 1 minus 5. Now I need to remember that in my original problem here, I had an x squared along with that, okay? So I can't forget my x squared. So I have 0 is equal to x squared times 2x plus 1 times x minus 5. So what makes this 0 is x equals 0. What makes this 0? I set it equal to 0 and I work it out and I get a -1/2. And what makes this 0 is 5. And so those are our x-intercepts. And that's the end of this video.